Right? A double angle formula is for this, right? The sine of 2u, that's a double angle because it's 2 times u. Okay. You can derive these formulas pretty easily. If you want to know what the sine of 2u is, then write it like sine of u plus u. So we can use our formula for the sine of the sum. It's just that actually both of the angles are the same thing. Right? We don't have a u and a v. We just got a u and a u. So when I use this formula, it'll look like sine u cosine u plus cosine u sine u. But those are the same thing. Right? It's just you reverse order the multiplication, but that's the same thing. So this is 2 sine u cosine u. And that is the formula for the sine of 2u. Right? These are the 3 double angle formulas. Right? There's the sine one that we actually just showed where it came from. You could do the same thing for the cosine, right? You could say cosine of u minus sine of u, and you will get cosine squared minus sine squared. Normally, that's not the form we use it, because remember, whenever we had an expression that was a mix of functions, we tried to make it all the same thing. Well, you can take this cosine squared minus sine squared and substitute either for cosine squared or for sine squared, so that it's all in terms of one of them. And you would get 2 different formulas, right? If it's all in terms of cosine, it looks like this. 2 cosine squared u minus 1. If it's all in terms of sine, 1 minus 2 sine squared u. They're all 3 valid, right? But we don't really use the first one very much. We definitely use the next, the ones that come after all the time. And then there is a formula for the tangent. But again, if you've already done the sine and the cosine, you could also just divide the sine and the cosine if you would have it. And again, you'll have these formulas on tests.